Okay, 2.8, last video. Composition of functions and their domains, more of a special type of composition. If f and g are functions, then the composite function, that's what I'll call this, or composition of f and g, is defined by, we can say fog of x, that's how I like to say it. It really means f of g of x, okay? So if you see this, it means this. So the domain of f of g is the set of all numbers x in the domain of g such that g of x is in the domain of f. Okay, so there's a little bit to that. The thing that you have to remember here is that you can't put anything into g, even if it's in the domain of g. If it's going to mess up f, then that's not going to work. So the easiest way that I know of doing this is to just go through, find the composite function, and then check each step to make sure you're never having any problems. You'll kind of see what I mean. So let's look at this one first, okay? Find fog of x and golf of x, right here, okay? And their domain, given f of x equals 8x plus 12 and g of x equals 3x minus 9, or minus 1. So the first thing I want you to notice here is both of those, their domains are all real numbers. That means I'll probably be okay on the compositions. Let's see how to do this. So f of g of x, that's going to be, I'm going to look at f, and everywhere I see an x, I'm going to put in g. So I'm going to say this is 8 times g plus 12, okay? Now I'll fill in what g is. This is 8 times g of x is 3x minus 1 plus 12. So altogether, I have 24x minus 8 plus 12. And then I'm going to simplify and see. Okay, well, 24x plus 4. And that's fully simplified. Now, for the domain of this, notice that there's no restrictions with my final answer, and there's no parts where I'm ever causing division by 0 or negative numbers under square root. So in that case, I feel comfortable saying the domain is negative infinity to infinity. Okay. Now let's go back here. Well, let's do golf of x. Golf of x is the same as g of f of x. So you can probably imagine what we have to do. We're going to look at g, and wherever we see an x, we're going to put in f. So this is going to be 3f minus 1. Fill in what f is. So 3 times 8x plus 12 minus 1. That's going to be 24x, so we're seeing that 24x again, plus 36 minus 1. And finally, we have 24x plus 35 for our final answer. So we're right here. Okay. And once again, there was no division by 0 or negatives under any square roots that ever happened. So I have all real numbers as my domain once again. Okay. Let's take a look at this one. It says, find fog of x and golf of x, given f of x equals square root x and g of x equals g of x equals x minus 1. So once again, fog of x is f of g of x. Okay. So I'm going to look at f, and wherever I see x, I'm going to put a g. Okay. So this is going to be the square root of g, which of course is the square root of x minus 1. So if we look at this, now that's fully simplified, we do have some restrictions on the domain, correct? Okay, so when I'm looking at this, this is fine. So the main restriction on the domain here is I can't have anything under the square root be less than 0, right? We can't have a negative under the square root. So the way I'll make sure that that doesn't happen is I'll take everything underneath the square root, and I'll say, okay, well, it has to be greater than or equal to 0, okay? So when I'm looking at this, I'm saying, okay, well, x is greater than or equal to 1. That's the only restriction. Okay. So my domain in this case is 1 to infinity. So nothing too new there. We just had to check our final part. Let's keep going. Golf of x is g of f of x. That's going to be g, but wherever we see an x, we're going to put f. So instead of x minus 1, I have f minus 1. So that's going to be square root of x minus 1. That's fully simplified. And once again, the only problem I have here is I need to make sure this is greater than or equal to 0. So that gives us our domain here. Our domain for this composition is from 0 to infinity. Okay. So nothing super interesting has happened, but let's look now at this one, okay? And this might be a good one to put a star by. Find fog of x given f of x equals 6 over x minus 3 and g of x equals 1 over x. So let's suppose you start this in the same way, okay? And you say, okay, well, I want f of g of x, okay? Now when we look at this, what we're going to get is we're going to get f, and wherever we see an x, I got to put in g. So I formed it just like that. So then that is going to be 6 over whatever g is, 1 over x minus 3. And what I want you to do at this point is to realize, oh, x cannot be equal to 0. We're going to keep track of that. Okay. Now, normally right here, I like to get common denominators. So I'll do that, and I'll tweak this one. So that'll get me to here. So I have 6 over, this is going to be 1 minus 3x over x. Okay. So I've already seen x cannot be equal to 0. I'm still going here. To divide by a fraction, let's multiply by the reciprocal. X over 1 minus 3x. And right here, I want you to notice this denominator can't be equal to 0. Okay, so I'll write that down here. 1 minus 3x cannot be equal to 0. 1 cannot be equal to 3x, meaning that x cannot be equal to 1/3. Okay, so I'm right here. I'm going to keep track of that. So finally, fully simplified, I get 6x over 1 minus 3x. There's my fully simplified form. Now, when I write this domain, I have to include both parts, because if you look at the final answer, it looks like x can be equal to 0, but we know that it can't from what we had earlier. So that's the way I like to handle the domains in examples like this. So the domain is going to be everything except for 0 and 1/3. So negative infinity to 0, union 0 to 1/3, union 1/3 to infinity. I would encourage you to maybe try g of f of x and see if you can figure out what that has to be. One last thing is, of course, we can identify certain things like f of g of 1. Okay, so what is f of g of 1 in this case? Well, f of g of 1, I could plug it right in here, and that would be fine. Or sometimes it's easier to figure out what g of 1 is first. So g of 1 would be 1. So f of g of 1 is the same as f of 1. F of 1 is 6 over 1 minus 3. That's 6 over negative 2 or negative 3. So just like before, there are multiple ways of doing these composite functions when you want to find a specific value. And you can do the same thing graphically, which you'll see in a few of the problems. Okay? So that wraps up 2.8, guys.